Hi class, this video is going to help with 9.2 or 2.2 in Business Calc. And this one is over infinite limits. So we covered limits where you're putting the value into the function to get that number. And we covered what to do if you had that indeterminate 0 over 0, which we had two methods that we learned. And now what if it's going to infinity or you're putting infinity into the function? Okay, so let me go ahead and share my screen, maybe, and share. Okay, so this is my first example, and again, this is infinite limits. If we have something like the function of 1 over x minus 1, okay, this is what our graph would look like. We'd have that asymptote at 1, and our graph would be going at that 1 would be going up to infinity and down to infinity. So what if I asked about the limit at the number 1? Okay, well, the limit at 1 doesn't exist. Okay, because the limit to the left and the limit to the right aren't going to the same spot, which we learned in our last one. But what if I asked the limit, I think I wrote this down. Yeah. But what if I ask the limit from the left side, from that negative side? Where is it headed to? Okay, so from the left side, it is headed to negative infinity. It's going down, 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 down. Okay, from the right side, it's going up to positive infinity. It's never going to cross the 1, but it's going to go up to infinity. So we can have the answer of infinity, not just a number, but it's going to negative infinity or it's going to positive infinity. Okay, so this is kind of like the way I kind of like to teach this a little bit different. I learned it from another colleague, but if we look at the limit as we're approaching this function from the positive side, so we have our little positive up there. So as we approach the 1, the way I want you to think of that is we know if we put 1 into our function, then we would get a 0 in the denominator. So we have a number over 0. That's what we're really looking at. And we know that in a lot of, or most cases, that means undefined. But let's think about this. We're looking at the number 1 or larger than 1 because we're on the right side. So it'd be smaller if we were on the left. If those numbers are larger than 1 and we minus 1, then they would be positive. Okay, so I'm thinking of this as a positive 0. So if I have a number over something positive 0, then I'm going to infinity. Okay, the other method, if this is confusing to you, so I can look at it and be like, well, it's going to infinity, and not everyone can look at it and understand that. So the other way is to use a table. We could check the graph as well, but that's not always that easy. So we could use a table. So we're on the positive side, so we're going to use 1.1. And so we'll put in that 1.1 into the function of 1 over x minus 1. And this one will get a 10. And then we're going to get a little closer to 1 from the positive side. And that's going to be 1.01. In that, when we get that one, we're going to get 100. And the next one, we get 1,000. And if you kept going, getting closer and closer and closer to 1, the numbers are getting bigger and they're positive. So it's going to positive infinity. Okay. So what could I do? I could think of it as a number over a 0 you're creating, but a positive 0. So it's going to positive infinity. You can use this idea, or you just make a chart. Make a chart. It's probably the best way. So let's look at the same idea with the negative. So if we have the limit as our x approaches our 1 from the left side, right, that negative of our function, then we have to think, well, it is smaller than 1. So when we subtract 1, we'd have a negative. So it's going to negative infinity. Okay, that's our idea. Well, how else could we do that? We could do our table. So this time we're a little bit on the left. So what are numbers of the left of 1 would be 0.9, 0.99, 0.999. That should have another 9. Okay, so when we put that in, we're going to get negative 10, negative 100, negative 1,000. So it is going to negative infinity, which we saw from the graph as well. Okay, so the charts are probably the easiest way. Okay, so let's look at this next example. So I have this function g, and the function is 1 over x minus 1 squared. Okay, so what if I'm asked, what's the limit as x approaches 1 from the positive side, okay, of this function? Well, from the positive side, they'd be a little bit bigger, so we're going to use our 1.1, our 1.01, our 1.001. And if we thought about that, that's going to give us a positive squared, which is a positive, so it's going to infinity. Okay, what's the other thing I could have done? Can't quite see my chart on the side there. Okay, I could have done putting in the values into the function right here, and I would have gotten huge numbers quick. Okay, and then you can see it's going to infinity. For part B, we can say, all right, well, what about from the left side? Okay, so I'm going to be putting in 0.9, 0.99. Both of these were going towards 1. I didn't mean to do that. But if you're going towards 2, then it would have been 1.9, 1.99. If this one up here, if we were going towards 2, it would have been 2.1, 2.01. So, you know, hopefully that makes sense that you could do that with different numbers too. Okay, so then this would also be going to positive because I would get a small number minus that is negative, but when I square, I get positive. So both the left and the right are going to infinity. So what can we say about the limit at this value 1? I feel like this keeps going out of focus. So what can we say? It actually has a limit. They're both going to positive infinity, so the whole thing is going to positive infinity at 1. So they both are going up like this. Okay, so the limit can exist because the left and right match. The last one, the limit didn't exist at 1. It only existed as you go from the left and from the right, and they were opposite. Okay. All right, let's see here. What if we have a function like x over x plus 1? So what if we, again, are looking from that left side? Okay, so if we're looking from that left side of this -7, which makes 0 in the denominator, which is what we're looking at on these, but we have our -7 up top, and we put in the -7 here and the -7 here. But when we're coming in from that left, we're going to be just a little smaller than a -7. What's a little smaller on a negative? Excuse me, is going to be that -7.1, because negatives are the other way. Draw a number line if you need to. Or the -7.01. -7.001. Excuse me. So if we have these numbers and we add 7, they're going to be negative because they're just a little bit bigger, negative bigger. So we would have a negative over a negative, which is a positive. Tricky. So if the top's negative, it's going to throw off a little bit. And we're putting in, we had to look at the negative there. So from the other side, then we're going to have that -6.9 because that's a little bit bigger. -6.99, again, a little bit bigger, and so forth. And again, you could use a chart and see this as well. So this is going to give us positive on the bottom, but we have a negative on the top. So this one's going to negative infinity. Okay, which overall means that the limit does not exist as you approach -7. Okay, does not exist there. It forms 0 in the denominator, and they're going the opposite ways. Okay. So on a lot of yours, you're going to have to check the left and right side to see if the limit exists on one in particular. Okay. Then we're going to kind of go a different direction. Okay, so what if I'm putting in infinity? Okay, so I have a little chart here. This is actually printed straight from your book. Okay, so this is theorem 4, limits and rationals. So let's look through this real quick. If the function looks like this, man, that's just, it looks ugly, but all I'm saying is it's a polynomial on top and it's a polynomial on bottom. So a number times x to some power plus a number times x to some power that's going down. So x squared x number, x to the third x squared x number. The limit as you approach infinity, as you're putting in infinity, this is going to be our rules of that basically. So there's possible cases. If m, that's our exponent on the top. Let me check something real quick. Meeting controls. I just didn't understand why that was highlighted. Hopefully I'm recording. You'll never see this if not. Okay, I have to start over. Okay, so if m is bigger, or excuse me, is less than n, so if m is less than n, these are all exponents, then the limit as you approach infinity is 0, okay? And that means we have a horizontal asymptote at y equals 0. So if the top's bigger than the bottom and you're putting in infinity, where are you headed? 0, okay? Or the top's bigger. I said it backward, didn't I? Top's bigger than the bottom. The top's smaller. So if I have x over x squared and I'm putting in infinity, where am I headed? 0, because the bottom's going to get so much bigger faster that it's going to be going to 0 because there'll be fractions and they'll be getting smaller, 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 smaller. Okay. If they're equal, so if I have x squared over x squared, then as I put in infinity, as I put in bigger and bigger and bigger and bigger numbers, you go to the fraction of the numbers in front. So you're going to the fraction of the numbers in front, okay? And it does have horizontal asymptote at y equals that, okay? So that's something you've learned before. If m is bigger than n, then you're going to be going to, as you could put in the infinity and the negative, depending, this is our hard case. If m is bigger than n, I thought I wrote it down a little bit different. Yeah, let me show you this. This is going to be our case where you have to use long division usually to help us. It's going to have a slant asymptote, which we've learned. It was in our review too, but it's going to have that weird slant asymptote. And you're typically going to infinity or negative infinity in this case. And that's why it's saying, yeah, I guess it did say it. The limit is going to be infinity or negative infinity. So you have to kind of play around with this. So this is where I have like x squared over x. It's not going to 0 now because the top's getting bigger faster. So you have to look if the top's getting negative big and the bottom's getting double negative big. You have to look at how it's going to be set up. So if the top is getting negative and the bottom is getting negative, then it's going to be a positive, negative over negative. If the bottom is a if you're a negative over a negative, it's going to be a positive, but if it's opposite, you're going to end up with negative. I don't know if I made sense by that. Hopefully, we'll see. Let's do an example. These are actually my favorite. I think they're easy, and I may not have explained the notation, but I want you to see that notation because that's what you're going to see when you look at the PowerPoints and other in the book and stuff. Okay, so if we want the limit as we approach infinity, so now we're approaching infinity of this function here. Well, we can see we have an x and an x, so they're equal. That means if I put in 10, then I would calculate, it's going towards 5/3. If I put in 100, it's going to 5/3. If I put in 1,000, it's going to 5/3. So it's getting closer and closer and closer to the fraction out front. Okay? So if they're equal in power, we just go to the fraction out front. All right, let's look at this one. If we're doing the limit as we approach infinity of x minus 5 over all this, we really are looking at that highest exponent on both, which is x over a square. So if we look at that, the bottom is getting bigger faster. What does that mean? It means you're going to 0. Okay, the bottom's getting bigger faster. So we're going to 0. I feel like I'm missing a I didn't show the last type. Let me see if there's one in here. I don't know why I didn't write down one of the last ones. 1, 2, 3, 4. Okay, here's one. So this is written a little bit different. This is just a worksheet that I would have typically given you in class if you're in person. So this one is saying, okay, as this function, if we put in a value like -10, where are we headed? Okay, so it's kind of leading you to that negative infinity. So if we put in -10, we're going to end up with -12 point whatever this is. Okay, if we put in -100, we're going to get a -1,245. So what's happening as we put in bigger negative numbers? We're going to get bigger negative. So we're going towards negative infinity. Okay, so the way that we could look at this really is, if we're asking the limit as we approach negative infinity, it's like I'm putting in negatives to the third, so they stay negative. Okay, and then this one would be a negative times a negative, which is a positive on the bottom. So it ends up being a negative. So what is the easiest way to look at this is it might be just to put in the values. And a lot of your homework does that for you. It's leading you to the answer by putting in a negative number and then another negative and so forth. Do I have any other? This one's just asking what the asymptotes are, which we reviewed in the beginning. I can show you. Remember, to find the asymptotes of something like this, you look at the denominator for your vertical asymptote, which on this one is x equals -5. And the horizontal asymptote on this would be 8, y equals 8, because it's where well, now I can't think of how to show you that. It's 8 over 1. Set it because it's the same exponent, or it's the same x and x, so it's set it to 8 over 1. No, it's making it harder than it is by looking at it weird. This one here is, there's no vertical asymptote, because if you set the denominator equal to 0, because of the square, it doesn't actually ever have a 0. So there's no vertical asymptote on this one. It doesn't ever equal 0. And then the top, if we look, it's a square over square, which is 3 over 3 or 1, so it's going to y equals 1. So I think you had some questions on asymptotes in here, if I remember right. This one has got the same over the same again, so the numbers in front are 1 over 1, so it's going to 1 for y equals 1. And this one you would have had to factor the denominator to get the two values of where the denominator equals 0. So in this homework, I'm pretty sure you have a couple that asks just about asymptotes as well. Okay, so I could go to infinity, all right, which I can see from a graph, as well as putting in values in a chart, or you could be putting infinity in, which is either going to 0 to a specific number, or it could be going to infinity or negative infinity. So I put in infinity and I'm going to infinity. All right, hopefully this helps. There's more extra videos from the company if you need those.